Okay, so now we proceed to 2.2. Given the quadratic number pattern -3, 6, 27 and 60 going forward. So we're going to answer the following question. So we're told that this is a quadratic number pattern. So there are questions that follow. So question 2.2.1. Let's attend to that. Determine the general pattern in the form of Tn is equal to an squared plus bn plus c. Determine the general term of the pattern in the form Tn is equal to an squared plus bn plus c. So they want us to determine the general pattern of this sequence or pattern in the form of Tn is equal to an squared plus bn plus c. So this is a quadratic sequence. So we're asked to find the general pattern of this sequence in this form. So what do we know about quadratic sequence? So the quadratic sequence has the second common difference. So on 2.1, we're dealing with the arithmetic sequence. It has the first common difference. So what is the second common difference? Let's go and examine that. So we have -3, we have 6, we have 27, we have 60, and so on. So when you find this difference, this is the first difference. So the first difference will be 6 minus -3, this is 9. 27 minus 6, this is 21. 60 minus 27, this is 33. This is the first difference. First difference. So the first difference is not common, it's not constant, it's changing. So the quadratic pattern have the second common difference. So if you find the difference here, it should be the same. So 21 minus 9, this is 12. 33 minus 21, this is 12. This is the second common difference. So this is how you identify the quadratic pattern. So they call this common difference just as D. So now they wanted us to find the general equation of this pattern. So let's go and do that. So here you haven't answered. We're going to start answering now. So we have that our D, our second common difference, is 12. So our general equation is Tn is equal to an squared plus bn plus c. To find a, so a is equal to d over 2. Our d is 12, the second common difference. So it's going to be 12 divided by 2, which is equal to 6. That is how you find a. Now that you have a, you can say Tn is equal to what? Is equal to 6n squared plus bn plus c. But you know, you are given other terms there. So your pattern, you are given, on this pattern, you are given the first term. The first term for this equation was, the first term for the equation, or for the pattern, was -3. So which means, if you substitute 1 here and 1 there, it should give you 6, because that's how you get the first term. So if I substitute 1 here and 1 here and whatever the value of C, it should give you the first term, which is -3. So you say, okay, my first term was -3, so -3 is equal to 6 into 1 squared plus B into 1 plus C, because that's how you find each and every term of the sequence once you have the general equation. Place 1 there, place 1 there, and that's C. It should give you 3. Similarly, for the second term was 6, which means now you have 6, when you put 2 here, plus B into 2 here, plus C. It should give you what? You should have 6 here. This is what this means. So what we do now is to simplify these two equations. So we have -3 is equal to 6 plus B plus C. Similarly, 6 is equal to, this is 6 times 4, because this is 4, 2 squared. You can punch it in a calculator. Find that this is 24 plus 2B plus C is equal to 6. So when you are here, you can solve this simultaneously, or elimination, which I always do. So 6, -3 minus 6, this is -9 is equal to 6 minus 24, -18 plus, B minus 2B minus B, C minus C, these cancel out. So you take this to the other side, you have -9 plus 18 is equal to -B, which you find out that 9 is equal to -B, which means that B is equal to -9. Because when you have B is equal to -9, divide by -1, divide by -1. That's how you give you -9. So you have your B, that your B is equal to -9. So now you have the second term, the second coefficient of this equation. Now you're left with 1. So let's go and update our equation. So Tn is equal to 6n squared minus 9n plus c. So in this case, we can use any term. For example, term 3, term 1. Because you know when you put 1 there, we'll get -3. So it's going to be -3 is equal to 6 into 1 squared minus 9 into 1 plus c. So -3 is equal to 6 minus 9 plus c, which is -3 is equal to 6 minus 9, which is -3 plus c. Then you transpose the c to this, the -3 to this side. It was negative to be positive, so you have -3 plus 3 is equal to c. Therefore, your c is equal to 0. So your general term for this equation is Tn is equal to 6n squared minus 9n plus 0, or just 6n squared minus 9n. That is your Tn here. So you can test this equation if it's correct by taking any of the 3 terms. So for example, let's say we take the second term. So T2 is equal to 6 into 2 squared minus 9 into 2. So can punch that in a calculator. So 6 into 2 squared minus 9 into 2. This is 6. And 6 was the second term of the equation. So you can do this for 1 as well. It should give out all the terms, which means now if you substitute 1, should give you the first term of the sequence. If you substitute 2, should give you the second term of the sequence. You can test that. This is how you find the general term of a quadratic equation. So I'm going to stop here.